Our teammates are Apurva, Bhumika, Kusuma. Our topic is looping and mathematical operations. Introduction. In 1885, microprocessors is capable of performing a wide range of arithmetic and logical operations using its instruction sets to handle repeated and interactive tasks efficiently and using the contributions branchings instructions are used. Looping means executing a set of instructions repeatedly until the certain conditions is met, while branching helps in changing the sequences of processing executions based on logical or arithmetic comprobations. This experiment to demonstrate how looping can be used to perform basic mathematical operations such as factorial of a number, greatest common divisors, square of number, sum of squares of a first n natural numbers. Each of those operations used fundamental arithmetic operations and looping control instructions to repeatedly process the data. Thank you. Next will be continued by Bhumika.
Abstraction. This were focused on a implementation illustrating the mathematical operation on a simple data set using a looping technology in an assembled language program. Since a microprocessor do not support a complex arithmetical instruction directly, operations such as factorial of components and greatest common derivation GCD, square of a number, and calculating the sum of the square of most be performed through investing and methods in the study for secure to express finding the factorial of the number stored in the memory. Determine a GCD of two number using a subtraction method. Computing the square of a number using a representation of addition. Evaluate the sum of the square of the first n natural number. Each task to determine the using loop and controls and determination operations and mathematical manipulation they have used in a highly important in a low level languages techniques in a achieve process control process. Next will be continued by Kusma.
Hello everyone, myself Apurva and I am handling with the output as shown in the image. First, the code is saved with the COA.asm with the extension of .asm. The purpose of the program is this finds the sum of squares of numbers starting from 1 up to a number n. Step by step explanation I am going to tell now. The number n is taken from the memory location 67H. Registers are set. R1 is equals to 0, which is used to store the running sum. R2 is equals to 1, used as a counter, starts from 1. The program goes into a loop, multiplies R2 into R2, for example, 1 into 1, 2 into 2, 3 into 3, and goes on. Add that squares value to R1, the total sum. Increases the counter R2 by 1. The loop keeps running until R2 becomes equal to n. Finally, the total sum of squares like 1 square plus 2 square plus 3 square plus up to n square is saved in the memory location 68H. Example, if n is equals to 3, result is equals to 1 square plus 2 square plus 3 square is equals to 14 and the value of 14 is stored at the 68H. Next program is about calculate the factorial of number n. The number n is taken from memory location 68. It copies this number into registers B for looping. The result register A is initialized to a 1 since factorial starts from 1. The program runs a loop. Multiplies A into B, for example 1 into 5, then 5 into 4, etc. Decreases B by 1 each time. Repeats this until b becomes 0. The final answer n factorial is stored in a memory location 61H. Example, if n is equals to 4, factorial is equals to 4 into 3 into 2 into 1 is equals to 24, which is stored at the address 61H. Thank you.